Chapter Review Question number 9. A mail order company pays for postage of its goods partly by destination and partly by total weight sent out on a particular day. The number of items sent out and the total weights were recorded over a 7-day period. The data are shown in the table. So here we have the number of items denoted by N and total weight Wkg. So in part A, the question says use coding x is equal to n minus 10 and y is equal to w divided by 400 to work out sxy and sxx. So first of all, we need to use coding and find the values of x and y. We will use the table given here. So these are the values that we need to use with coding to find x values and y values. So x is equal to n value minus 10. So we will take each n value from here, and from the n value we will subtract 10, and that will give us the x value. So the first value is 10. 10 minus 10 is going to give us 0. Our second value is 13. 13 minus 10 will give us 3. Our third value is 22. 22 minus 10 will give us 12, and so on and so forth. We will find out all the x values. Then we next move on to finding the y values. We can find y values by w divided by 400. So we take each value of w and divide it by 400. So 2800 divided by 400 gives us 7. 3600 divided by 400 gives us 9, and so on and so forth. We find all the values by dividing w's by 400, and we find the corresponding y value. Now that we have all the x and the y values, we will move on to finding sxy and sxx. So we know the formula for sxy. Sxy is equal to sigma xy minus sigma x into sigma y divided by n, and sxx is equal to sigma x squared minus sigma x the whole squared divided by n. So let's plug in the values. I have already found the values of the required values that we need to plug in here. So sigma xy, we find this by taking the x value, multiplying it by y, and then adding to it the next value of x multiplied by y, and then adding to it 12 into 15, and so on and so forth. Sigma x we get by adding all the x values, and sigma y is adding all the y values that we have here. Sigma x squared is taking the x value, first squaring it, then adding it to the square of the next x value, and so on and so forth, adding up all the x squares. So since I have all the values here, I can just plug in and find the value of sxy and sxx. So sigma xy is 617. So we have 617 minus sigma x, which is 49, multiplied by sigma y, which is 77, divided by the total number of days, which is 1, 2, 3, 4, 5, 6, 7, as it is over a 7-day period. So we divide it by 7, and once we calculate, we get the value of sxy as 78. We can write it here. This is equal to 78. For sxx, we have 491, which is sigma x squared, minus sigma x, which is 49, the whole squared, divided by 7, and that gives us the value of Sxx, which is 148. So here we have found the value of Sxy, which is 78, and we have found the value of Sxx, which is 148. Sorry about the cramped space. Okay, so moving on to the part B. So this was part A that I have answered here. So this is part A of the question, which I have answered here. Moving on to the part B. Part B says, work out the equation of the regression line of y on x. So we know that equation of regression line of y on x is in the form of y is equal to a plus bx. So when we need to find the equation of the regression line, all we need to do is to find the value of a and find the value of b. So let's start by finding the value of b. So b is equal to Sxy divided by Sxx. We have already found Sxy and Sxx. So all we need to do is to divide 78 divided by 148, and that is equal to 0.52702. 52702. So that was the value of b. Now we know that we need to find the value of a also for the equation of regression line. For that we need to make a the subject of formula, and we can do that by taking the term bx to the other side. So we have a is equal to y minus bx. So average value of a is equal to average value of y minus b, which we just found in this part here. We found b into average value of x. So let's plug in these values to find average value of a. So we have average value of y, which is the total value of y is 77. That is the total of all the readings of y's, 7 plus 9 plus 15, all of them till end. So since we have to find the average value, we will do 77 divided by 7, which will give us 11. So the average value of y is 11 minus the b value, which we have already, 0.52702, multiplied by the average value of x. So we have the total value of all the x's added, or summation x is 49. Average is 49 divided by 7, as we have 7 entries of x. 49 divided by 7 is 7. Therefore, the average value of x is 7. And hence, when we calculate the value of a, we get 7.31. We can round it off. So I will round it off to 4 significant figures, 7.311. And that gave us the value of a. Now we can write the equation of regression line, as we have already got the value of a that we were looking for and b, and we know that all we need to do to find equation of regression line is to plug it in into this given equation. So let's do that. We will plug in. So we have y is equal to 7.311 plus 0.527 into x, and that is the equation of regression line of y on x, and it is our answer to part B. Moving on to part C, work out the equation of regression line of w on n. Now we have got the equation line of regression line of y on x. Now we can use the coding to find the equation of the regression line of w on n, and all we need to do is to replace the y with w upon 400 as y is w upon 400 and to replace the x with n minus 10. So let's do that to find the answer for part C. So we are moving to part C. We have already got the equation of regression line. Y will be substituted by w over 400. So we have w over 400 is equal to 7.311 plus 0.527 and x will be substituted by n minus 10. So we will leave the w over 400 for now here. We have 7.311. We will multiply the number 0.527 with n and with negative 10. So we have 7.311 plus 0.527n and the number 0.527 when multiplied by negative 10 gives us minus 5.27. Now we add up the two like terms here. We have a constant 7.311 and a constant minus 5.27. So we can add these two. So we have w over 400 is equal to 2.04 plus 0.527n. In the next step, what we will do is we will take the 400 and multiply it onto the right hand side. We know that when a factor which is in the division goes to the other side, it becomes multiplication. Therefore, we have w is equal to 400 into 2.04 plus 0.527n, and when we work that out we get the equation of the regression line, which is w is equal to 816 plus 210.8n. So that answers for the part C, which is equation of the regression line of w on n. So this is the answer for part C. Moving on to part D. So now we are moving to part D. Part D says use your regression equation to estimate the value of 20 items. So we know that number of items here to be plugged in is 20. So all we need to do is to plug in 20 for n and find the value of the weight of 20 items. So the weight w is equal to 816 plus 210.8 times 20, and when we work that out we get the total weight for 20 items to be 5032 kg. Now in part E we need to answer, state why it would be unwise to use the regression equation to estimate the weight of 100 items. Now, what we have done in part D is to estimate the weight of 20 items, and now we are being asked why would it be unwise to estimate the weight of 100 items. So let us try it out first to estimate the weight of 100 items. Weight is equal to 816 plus 210.8. Now we are trying to estimate the weight of 100 item, and when we work that out we get the weight as 21,896 kg. Now, why would this be unwise? If we look at the if we look at the n value that we have substituted, which is number of items, is 100. Now the x values that we are working with are values like 0, 3, 12, maximum value is 14. So clearly 100 is a value which is outside the range of values. We can see that. And that's why it is an extrapolation. Extrapolation means taking the value which is outside range. And hence it would be it is unwise to use the regression equation to estimate the value of 100 items. So we will write the answer here. So it is number of items 100, number of items equals 100 is a value outside the range. So it is outside the range. Therefore, it is an extrapolation. And hence it is unwise to calculate weight for 100 items.